Hi, hello, this is Giri, teaching 10th Mathematics, the chapter Polynomials. Here are the questions and solutions from exercise 3.3 and this is part 2 video. In this video, we will learn the solutions of question number 3 and question number 4 of the exercise 3.3 and this is question number 3. Find the quadratic polynomial in each case with the given numbers as zeros of the polynomial. First bit 2 minus 1, second bit root 3 minus root 3, fifth bit 1 by 2 and 3 by 2. I shall repeat. Find the quadratic polynomial in each case with the given numbers as zeros of the polynomial. First bit 2 minus 1, second bit root 3 minus root 3 and fifth bit 1 by 2 and 3 by 2. Look at the solution now. The first bit is these two are the zeros. One value is alpha and the second value is beta. Alpha is equal to 2 and beta is equal to minus 1. Then sum of the zeros alpha plus beta. 2 minus 1 is 1. And product of the zeros alpha into beta. 2 into minus 1 is minus 2. Now, whenever you know the zeros, straight away you can find the sum of the zeros and product of the zeros. If once you know the sum of the zeros and product of the zeros, then you can use the formula that the quadratic polynomial with alpha plus beta and alpha and beta is x square minus alpha plus beta into x plus alpha into beta. Now substitute the values. This is equal to x square minus alpha plus beta value is 1 into x plus alpha into beta is minus 2. This is x square minus 1 into x is minus x plus into minus 2 is minus 2. This is the quadratic equation with the zeros 2 and minus 1. Now look at the second bit. It is given that alpha first 0 is root 3 and beta second 0 is minus root 3. Then sum of the zeros plus root 3 minus root 3 will be cancelled. Sum of the zeros is 0. And product of the zeros alpha into beta. Root 3 into plus into minus is minus. Root 3 into root 3 is 3. Alpha into beta is minus 3. Now the quadratic polynomial with alpha plus beta and alpha into beta is x square minus alpha plus beta into x plus alpha into beta. Now substitute the values again. This is equal to x square minus alpha plus beta value is 0 into x plus alpha into beta is minus 3. This is equal to x square 0 into x is 0 plus into minus 3 is minus 3. Therefore the quadratic polynomial is x square minus 3. In which the zeros are minus root 3 and plus root 3. Now fifth bit, it is given that alpha is equal to 1 by 2 and beta is equal to 3 by 2. Then alpha plus beta, sum of the zeros 1 by 2 plus 3 by 2. 2 is the LCM, 1 plus 3 is 4 by 2 which is equal to 2. Then alpha into beta, product of the zeros. Alpha into beta is 1 by 2 into 3 by 2. 1 into 3, 3. 2 into 2, 4. Alpha into beta is 3 by 4. Now the quadratic polynomial with alpha plus beta and alpha into beta is x square minus alpha plus beta into x plus alpha into beta. Now substitute the values again. Here if you substitute, this is x square minus alpha plus beta value is 2 into x plus alpha into beta is 3 by 4. Since 4 is there in the denominator, let us multiply all the three terms with 4. Then 4 into x square is 4x square minus 4 into 2x, 4 2 is 8x. 4 and by 4 will be cancelled, you will get 3. Therefore, the required quadratic polynomial with 1 by 2 and 3 by 2 is 4x square minus 8x plus 3. Now, the question number 4. Here is the question number 4. Verify that 1, minus 1 and minus 3 are zeros of the cubic polynomial x cube plus 3x square minus x minus 3 and check the relationship between zeros and the quotients. I shall repeat. Verify that 1, minus 1 and minus 3 are the zeros of the cubic polynomial x cube plus 3x square minus x minus 3 and check the relationship between zeros and the quotients. Here is the solution. It is given that The polynomial p of x is equal to x cube plus 3x square minus x minus 3. This is the cubic polynomial. Since it is the cubic polynomial, there may be 3 zeros. Here we have to verify whether 1 is a 0 of this, whether minus 1 is a 0 of this, whether minus 3 is a 0 of this. Now in order to verify whether a particular value is a 0 of the polynomial or not, you have to substitute that value in the place of variable. If we get the value of the total polynomial becomes 0, then that value itself is the 0 of the polynomial, you can say. Therefore, let us verify by taking x is equal to 1. If we take x is equal to 1, then p of 1 is equal to 1 cube. X cube means 1 cube. 3 into x square means 3 into 1 square. Minus x means minus 1, minus 3. 1 cube is 1. 1 square is 1 into 3 is 3. Minus 1 minus 3 is minus 4. What is 1 plus 3? 1 plus 3 is plus 4 minus 4, which is equal to 0. Now if you substitute x is equal to 1, we got the value of the polynomial 0. Since the value of the polynomial is 0 at x is equal to 1, this 1 is one of the zeros of the given polynomial. Now verify with minus 1. Let x is equal to minus 1. If x is equal to minus 1, then p of minus 1 is equal to x cube minus 1 whole cube plus 3 into x square minus 1 whole square minus x means minus 1 minus 3. Minus 1 whole cube minus to the power an odd number is minus. 1 into 1 is 1. Minus 1 whole square is plus 1 into 3 is plus 3. Minus of minus 1 is plus 1 and this is minus 3. 1 plus 3 is 4. Minus 1 minus 3 is minus 4. 4 minus 4 is 0. Again, whenever you substitute x is equal to minus 1, we got the value of the polynomial 0. So that minus 1 is also a 0 of the polynomial. Now let us check with minus 3. Let x is equal to minus 3. If x is equal to minus 3, then p of minus 3 is equal to x cube minus 3 whole cube plus 3 into x square minus 3 whole square minus x means minus of minus 3 and minus 3. Now if you observe, minus to the power an odd number is minus. 3 cube means 3 into 3 into 3. 3 3 is 9, 9 3 is 27. Minus 3 whole square is plus 9 into 3 is plus 27. Minus of minus 3 is plus 3 and this is minus 3. 27 plus 3 is 30. Minus 27 minus 3 is minus 30. 30 minus 30 is 0. Again, if we substitute x is equal to minus 3, we got the value of the polynomial 0. Since the value of the polynomial is 0, when you substitute x is equal to 1, x is equal to minus 1 and x is equal to minus 3, these 3 are the zeros of the polynomial. Since p of 1 is equal to 0, p of minus 1 is equal to 0 and p of minus 3 is equal to 0. 1, minus 1 and 3 are the zeros of the given cubic polynomial. Here you may consider the first 0 as alpha and second 0 as beta and third 0 as gamma. Alpha is equal to 1, beta is equal to minus 1 and gamma is equal to minus 3. We have given the polynomial px is equal to x cube plus 3x square minus x minus 1. A means coefficient of x cube is 1. B coefficient of x square is plus 3. And C coefficient of x is minus 1. And D constant term is minus 3. Here we checked whether this 1, minus 1 and minus 3 are zeros or not. It is the first part of the question. Now the second part is we have to check whether the relationship holds good or not. The relationship between zeros and the coefficients of the cubic polynomial holds good or not. For that, we consider the cubic polynomial law. Take the coefficients. Coefficient of x cube is a, coefficient of x square is b, coefficient of x is c, and constant term is d. A is equal to 1, b is equal to 3, c is equal to minus 1, d is equal to minus 3. And alpha is equal to 1, beta is equal to minus 1, and gamma is equal to minus 3. Now let us find the sum of the zeros, alpha plus beta plus gamma. Alpha value is 1, beta value is minus 1, gamma value is minus 3. 1 minus 1 is 0, minus 3 is minus 3. Sum of the zeros is minus 3. Now let us find minus b by a. minus b means minus 3 by a is 1, minus 3 by 1 is minus 3. If you observe, these two values are equal, so that you can say that alpha plus beta plus gamma is equal to minus b by a. Understood? Now let us find alpha into beta plus beta into gamma plus gamma into alpha. Alpha into beta 1 into minus 1 is minus 1. Beta into gamma minus 1 into minus 3 plus 3. Gamma into alpha minus 3 into plus 1 is minus 3. Now if we add these three, minus 1 plus 3 minus 3 will be cancelled. This is minus 1. We got alpha into beta plus beta into gamma plus gamma into alpha value minus 1. Now let us find the value of c by a. C by a, c value is minus 1 by a value is 1. Minus 1 by 1 is also minus 1. If you observe, these two values are equal. Therefore, you can say that alpha beta plus beta gamma plus gamma alpha is equal to c by a. It is the second relation. Now let us find the product of the zeros, alpha into beta into gamma. 1 into minus 1 into minus 3. 1 into minus 1 is minus 1. Minus 1 into minus 3 is plus 3. Let us find the value of minus d by a. Minus, what is d value? D value is minus 3. By a value is 1. Minus of minus is plus. 3 by 1 is 3. If you observe, these two values are equal, so that you can say that alpha into beta into gamma is equal to minus d by a. These are the three relationships. Whenever you have given a cubic polynomial, then these are the three relationships between the zeros alpha, beta, gamma and the coefficients a, b, c, d of the cubic polynomial. You verified all these values found correct. Therefore, the relationships between the zeros and the coefficients are verified. All the video links of chapter 1 relationships, chapter 2 sets and the previous videos of this third chapter polynomials are given in description. You may please click them and revise whichever video you want, you can revise. Thank you one and all.